The Galactic Infrastructure Council had operated for 12,000 years without a single challenge to their monopoly. Their massive space elevators, quantum tunneling networks, and antimatter refineries stretched across 47 star systems, generating profits that dwarfed the gross domestic products of entire worlds. When humanity applied for membership in the Galactic Trade Federation, the Council's response was predictably dismissive. Primitive chemical rockets, Council Chairman Vextar had sneered during the closed session. His crystalline exoskeleton caught the artificial starlight filtering through the orbital headquarters. They burn fossil fuels to escape their gravity well. How quaint. The other council members, representing the most technologically advanced species in known space, shared his amusement. The Zephyrians' energy-based forms flickered with what passed for laughter among their kind. The massive Kronak delegation rumbled their approval through translator modules that made their subsonic communications audible to smaller species. Dr. Marcus Chen, humanity's chief engineering representative, sat quietly at the far end of the council chamber. His simple gray suit and worn leather briefcase seemed pathetically mundane compared to the exotic technologies surrounding him. The other species had arrived in vessels that defied conventional physics, their personal accessories incorporating technologies that humanity was only beginning to theorize about. Dr. Chen, Chairman Vextar's translator, rendered his clicking communication into standard Galactic. Your species has submitted an application for infrastructure development rights. The Council finds your technological base insufficient for our standards. Marcus stood slowly, his movements deliberate and measured. At 45, he carried himself with the quiet confidence of someone who had spent decades solving impossible problems. His hands were calloused from working with tools, his eyes sharp with the intelligence that had earned him 3 doctorate degrees before his 30th birthday. Chairman Vextar, respected council members, Marcus began, his voice steady despite the magnitude of the moment. I understand your concerns about our current technology. Our rockets do indeed use chemical propulsion. Our computers still rely on silicon-based processors. By your standards, we are primitives. A ripple of what might have been condescending approval passed through the chamber. Several delegates exchanged what were clearly the galactic equivalent of knowing glances. However, Marcus continued, opening his briefcase and removing a single sheet of paper. I would like to present a different perspective on human engineering. The paper looked absurdly antiquated in the high-tech environment. Hand-drawn diagrams covered its surface, accompanied by mathematical equations written in neat, precise handwriting. Marcus held it up for the chamber to see. This is a design for a self-assembling orbital construction system. The initial component weighs approximately 50 kilograms and can be launched using our primitive chemical rockets. Within 6 months of deployment, it will have constructed a space elevator capable of lifting 1 million tons of cargo per day. The chamber fell silent. Chairman Vextar's translator remained quiet for several seconds before he spoke again. That is impossible. Our most efficient space elevators require 2 years of construction using gravitational manipulation technology. The materials alone weigh more than your entire industrial output. Marcus smiled for the first time since entering the chamber. It was not a pleasant expression. With respect, Chairman, that is because you build space elevators the way your species has always built them. Massive, complex, requiring enormous resources and advanced materials. You think like beings who have unlimited energy and exotic matter at their disposal. He walked to the center of the chamber, his footsteps echoing in the sudden quiet. Humans think differently. We have spent our entire existence working with limited resources. Every calorie mattered for our hunter-gatherer ancestors. Every gram of payload matters when you're escaping a gravity well with chemical rockets. We have learned to do more with less not because we are primitive, but because we have no choice. Marcus placed the paper on the central display table. The chamber's advanced scanning systems immediately began analyzing the design, projecting holographic representations into the air above the document. This system uses biomimetic manufacturing principles based on how coral reefs grow. Each component is designed to harvest materials from space debris, asteroids, and solar radiation. Instead of shipping massive prefabricated sections, we ship self-replicating seed units that build exactly what they need from whatever is available. A holographic projection began animating the construction process. Small units attached to space debris, gradually breaking down and reshaping materials. Within the simulation, structures began to emerge and grow organically. Council member THYSS, representing the Zephyrian energy beings, flickered rapidly, their species equivalent of intense concentration. The power requirements for molecular manipulation on this scale would be enormous. No chemical process could provide sufficient energy. You're correct, Marcus acknowledged. Which is why the system doesn't rely on chemical power after initial deployment. Each construction unit incorporates photovoltaic collection surfaces and low-efficiency fusion initiators. The energy systems grow with the structure, becoming more sophisticated as construction progresses. The Chronac delegate's translator crackled with static before producing words. This design requires impossible precision in manufacturing. Tolerances measured in molecular scales. Your metallurgy cannot achieve such precision. Marcus nodded thoughtfully. Again, you're correct about our current manufacturing capabilities. But, you're thinking like beings who need to build perfect components from the beginning. This system is designed to start with imperfect components and gradually improve them through iterative construction. The holographic display shifted, showing how early construction phases produced crude but functional components. As the system grew, it developed more sophisticated manufacturing capabilities, eventually producing components with atomic-level precision. Each generation of construction improves on the previous generation. The system learns, adapts, and evolves. Within 6 months, components that started with millimeter tolerances are building structures with subatomic precision. Chairman Vextar's exoskeleton began changing color, a sign of extreme agitation among his species. This violates fundamental engineering principles. Complex systems cannot emerge from simple ones without external guidance. With respect, Chairman, that assumption is why your infrastructure systems are so expensive and time-consuming to build. You assume that complexity must be imposed from outside. Human engineers learned long ago that complexity can emerge from within a system if you design the right initial conditions. Marcus gestured to the animated display, which now showed a fully functional space elevator growing from what had started as a collection of simple components. We call this emergent engineering. Instead of trying to control every aspect of construction, we create conditions where the desired outcome emerges naturally. It's the same principle that allows a single human cell to grow into a complete organism containing trillions of specialized cells. The chamber erupted in what passed for heated discussion among the various species. Translators worked overtime as delegates argued among themselves about the feasibility of what they were seeing. Dr. Cathmori, the senior scientific advisor to the council, finally spoke. His species was known throughout the galaxy for their analytical minds and conservative approach to new technologies. Dr. Chen, even if your design is theoretically sound, the resource requirements would still be substantial. Our economic models show that even our most efficient construction techniques require significant upfront investment. How do you propose to finance such a project? Marcus's smile became genuine for the first time. Dr. Cathmori, that question reveals the fundamental difference between human engineering and galactic engineering. You're asking about financing because you're thinking about this as a construction project. We're thinking about it as a farming project. The confused silence that followed encouraged Marcus to continue. When a farmer plants seeds, he doesn't buy corn. He invests in potential corn. The seeds use energy from the sun and materials from the soil to create something much more valuable than the initial investment. Our engineering seeds work the same way. He touched the display controls, shifting the projection to show economic projections. The initial 50 kg seed unit costs approximately 50,000 galactic credits to manufacture and deploy. Within 30 days, it has harvested enough space debris to construct manufacturing capabilities worth 10 times that investment. Within 60 days, the growing structure is producing components more sophisticated than anything we could have launched from Earth. The economic projections showed exponential growth curves that made several delegates recoil in surprise. By day 90, the system is not only paying for itself but generating surplus materials that can be sold on galactic markets. By day 180, it has produced infrastructure worth more than your largest space elevator project, at a fraction of the cost. Council member RYTHOK, whose species controlled the largest asteroid mining operations in the galaxy, spoke for the first time. This level of autonomous manufacturing would destabilize existing markets. If any species could build space elevators in 6 months using space debris, the value of our mining operations would collapse. Only if you continue thinking like miners instead of thinking like farmers, Marcus replied calmly. Instead of extracting finite resources, you could be cultivating infinite ones. Instead of depleting asteroids, you could be growing them. The suggestion caused an even greater uproar. The concept of growing asteroids violated so many assumptions about physics and economics that most delegates couldn't even begin to process the implications. Marcus waited for the noise to subside before continuing. Human engineers learned something important during our Industrial Revolution. The most valuable resource isn't matter or energy. It's information. The ability to organize matter and energy in useful ways. He gestured to the holographic display, which now showed multiple space elevators growing simultaneously from single seed units. Every atom in this room has existed for billions of years. The iron in my blood was forged in the heart of a dying star. The carbon in my bones was once part of ancient organic molecules. Matter is abundant. Organization is rare. The chamber fell silent as delegates considered this perspective. Your species have focused on finding and extracting organized matter, rare elements, complex compounds, exotic materials. You've built an entire galactic economy based on the assumption that organization is something you must discover and extract from nature. Marcus's voice grew stronger as he continued. Humans discovered that organization is something you can create. With the right information, any collection of matter can be reorganized into any other collection of matter. The limitation isn't resources, it's knowledge. Dr. Cathmory's analytical mind struggled with the implications. You're suggesting that your species has developed information-based manufacturing techniques that can reorganize matter at the atomic level? Not just suggesting, Dr. Cathmory. Demonstrating. Marcus reached into his briefcase and withdrew what appeared to be a simple metallic sphere about the size of a baseball. This sphere contains the same information as that paper design, encoded in self-executing molecular machinery. With your permission, I would like to activate it. The request caused immediate alarm among several delegates. Security protocols activated automatically, scanning the sphere for potential threats. Chairman Vexstar's translator remained silent for nearly a full minute before he responded. Our security systems detect unusual atomic arrangements within your device, but no conventional weapons signatures. What exactly are you proposing? I'm proposing a demonstration. Your orbital headquarters has approximately 50 tons of space debris in its immediate vicinity, spent fuel containers, discarded equipment, normal maintenance waste. This sphere can use that debris to construct a functional manufacturing node within 72 hours. The security implications sent several delegates into immediate conference with their respective governments. The idea of activating unknown human technology near the galactic government's headquarters violated every safety protocol in existence. But Dr. Cathmory's scientific curiosity overcame his caution. What would this manufacturing node produce? Whatever we need, Marcus replied simply. The node is designed to analyze available materials and construct useful products. In this case, it would likely produce communication enhancers, life support improvements, and structural reinforcements for the station. He paused, watching the delegates process this information. But, more importantly, it would produce copies of itself. Within 1 week, you would have a dozen manufacturing nodes. Within 2 weeks, you would have 100. Each one learning from the others, improving their designs, becoming more sophisticated. The implications were staggering. Several delegates began rapid calculations, trying to understand the exponential growth patterns Marcus was describing. Of course, Marcus continued conversationally. If you prefer, you could continue using your current infrastructure systems. Mining asteroids for raw materials, shipping them across interstellar distances, assembling them using conventional techniques. It only takes 2 years and costs approximately 10 billion credits per space elevator. He gestured to the display showing the cost comparisons. Or you could activate 150 kilogram seed unit, wait 6 months, and have a space elevator that cost 50,000 credits and builds copies of itself from space debris. The economic implications were becoming clear to every delegate in the chamber. The Galactic Infrastructure Council's entire business model was based on scarcity, scarce materials, scarce manufacturing capabilities, scarce expertise. If humans could eliminate scarcity through information-based manufacturing, the Council's 12,000-year monopoly would become worthless overnight. Council member Vothran, whose species controlled the galactic shipping industry, finally voiced what everyone was thinking. If your claims are accurate, Dr. Chen, you are not simply requesting membership in our trade federation. You are proposing to eliminate the economic foundation of galactic civilization. Marcus nodded seriously. Counselor Vothran, that's exactly what I'm proposing. But, not to eliminate it, to evolve it. He walked back to the display controls and called up a new set of projections. Every major technological revolution in human history has eliminated existing economic structures while creating new ones. When humans developed agriculture, we eliminated the scarcity-based economy of hunter-gatherer societies. When we developed manufacturing, we eliminated the labor-based economy of agricultural societies. When we developed information technology, we eliminated the material-based economy of industrial societies. The projections showed human economic development over thousands of years, each revolution creating abundance where scarcity had existed before. Each transition seemed catastrophic to the established powers of the previous era. But each transition also created opportunities that the previous era couldn't have imagined. Chairman Vextar's color shifts had become more pronounced. You speak of transitions that occurred within a single species on a single world. Galactic civilization involves thousands of species across dozens of star systems. The economic disruption you propose could destabilize governments and trigger resource wars. Only if those governments and species continue thinking like scarcity-based civilizations, Marcus replied. The transition we're offering isn't just technological, it's conceptual. Instead of fighting over limited resources, galactic civilization could focus on creating unlimited ones. The chamber fell silent again as delegates struggled to comprehend the scope of what Marcus was proposing. Let me be clear about what I'm offering, Marcus said, his voice carrying across the chamber with quiet authority. Humanity is prepared to share our emergent engineering technologies with every member species of the Galactic Federation. Free of charge. No licensing fees, no usage restrictions, no territorial limitations. The statement sent shockwaves through the assembled delegates. In a galaxy where technological advantages were carefully guarded secrets worth more than entire planets, the offer to share advanced manufacturing techniques freely was unprecedented. In return, Marcus continued, we ask only for the opportunity to participate as equals in galactic civilization. Not as junior partners who must license your technologies at ruinous cost, but as contributors who offer something valuable to the galactic community. Dr. Kethmori leaned forward in his analysis posture. Dr. Chen, your offer is unprecedented. But surely you understand that such radical changes cannot be implemented without extensive testing and verification. Even if your technologies work as claimed, the social and economic implications require careful study. Marcus nodded in agreement. Absolutely, Dr. Kethmori. Which is why I'm proposing a limited demonstration. Allow me to activate this manufacturing seed in a controlled environment. Monitor its development. Study its capabilities. Analyze its economic impact. He held up the metallic sphere. If our technologies prove disappointing, you've lost nothing except a few tons of space debris. If they work as promised, you'll have the opportunity to observe the future of galactic manufacturing firsthand. Chairman Vextar's exoskeleton had stabilized to a deep orange color that indicated serious consideration among his species. Dr. Chen, you must understand that the decision to test unknown human technology near our headquarters requires approval from the full Federation Council. Such authorization could take weeks or months to obtain. I understand completely, Chairman. But, I should mention that this offer has a time limitation. The statement caused immediate concern among several delegates. Time limitation? Council member THYS's era flickered rapidly. Are you threatening the council? Marcus's expression remained calm. Not threatening, Counselor. Simply acknowledging reality. Humanity has shared these technologies with several non-Federation species who were more receptive to innovation. The Altarian Republic has been testing our manufacturing systems for 3 months. The Centauri Alliance activated their first space elevator last week. The news sent the chamber into chaos. If humanity had already shared their technologies with non-Federation civilizations, the strategic implications were enormous. The Federation has perhaps 60 days before our manufacturing technologies become available through other sources, Marcus continued over the noise. After that point, your decision to test our systems becomes irrelevant. You'll be able to observe their capabilities by monitoring non-Federation infrastructure development. The statement was not quite a threat, but it carried clear implications about the Federation's future position in galactic politics. Chairman Vextar called for order, but the damage was done. Every delegate was now calculating how quickly their governments could evaluate and, potentially adopt human technologies. Dr. Chen, the chairman said finally, your presentation has given the council much to consider. We will need time to evaluate your proposals and consult with our respective governments. Marcus picked up his briefcase and the paper with his hand-drawn designs. Of course, Chairman. I'll be available at the Human Embassy for the next 72 hours. After that, I'll be returning to Earth to oversee our next round of technology transfers. As he walked toward the chamber exit, Marcus paused and turned back to address the assembled delegates. Members of the Council, I want you to understand something important about human engineers. We don't build things because we want to control them. We build things because we want to understand them. The greatest reward for solving a difficult problem isn't profit or power, it's the opportunity to solve an even more difficult problem. He gestured toward the holographic display, which still showed the growing space elevator. You've spent 12,000 years perfecting the art of extracting value from scarcity. Humans spent thousands of years perfecting the art of creating value from abundance. We're offering to teach you not because we want to dominate galactic civilization, but because we want to see what galactic civilization can build when it's no longer limited by scarcity. The chamber door closed behind him with a soft hiss, leaving the most powerful beings in galactic civilization to contemplate the possibility that everything they thought they knew about engineering, economics, and power was about to become obsolete. In the silence that followed, Dr. Kethmori spoke the thought that was on everyone's mind: what if he's right? The emergency session of the Galactic Infrastructure Council convened 18 hours after Marcus Chen's departure. Every delegate had spent the intervening time in urgent communication with their home governments, and the atmosphere in the chamber crackled with tension and barely concealed panic. Chairman Vextar's exoskeleton had shifted to deep crimson, a color his species reserved for crisis situations. Distinguished delegates, our intelligence services have confirmed Dr. Chen's claims regarding non-Federation testing of human technologies. The Altarian Republic has indeed constructed what appears to be a functional space elevator in their outer system. The confirmation sent ripples of alarm through the chamber. Councilmember R. Whitehoke's massive frame shuddered as his translator processed his subsonic communications. Our long-range sensors detected the structure 3 days ago. We assumed it was a conventional construction project using stolen Federation technology. It was not, Dr. Kethmori announced, his analytical calm barely masking his excitement. I have completed a detailed analysis of the holographic projections from Dr. Chen's presentation. The mathematical principles are sound, but they represent a fundamental departure from conventional engineering approaches. The chief scientist activated the chamber's display systems, projecting complex mathematical equations into the air above the central table. Traditional galactic engineering focuses on precision control of complex systems. We design structures with detailed specifications and build them using predetermined processes. Human engineering appears to focus on simple rules that generate complex outcomes through iteration. The equation showed comparative analysis between galactic and human design methodologies. It is analogous to the difference between sculpting and gardening. We carve structures from raw materials using precise tools. Humans plant seeds and create conditions for structures to grow organically. Council member HFY Stories' energy form flickered rapidly. Dr. Cathmori, are you suggesting that human engineering is actually superior to our established methods? Not superior, counselor. Different. And potentially more efficient for certain applications. The scientist's admission sent shockwaves through the chamber. Our methods excel at creating precise, controlled structures using known materials and established techniques. Human methods excel at creating adaptive structures using available materials and emergent techniques. Chairman Vextar struggled to maintain his diplomatic composure. Dr. Cathmori, you are describing engineering approaches that could revolutionize galactic manufacturing. Why have our scientists not developed similar techniques? The question hung in the air as Dr. Cathmori considered his response. Finally, he spoke with the careful precision of someone delivering unwelcome news. Because, Chairman, we never needed to. Every major species in the Federation evolved on worlds with abundant resources and developed technologies under conditions of relative plenty. Our engineering traditions developed around the assumption that materials, energy, and time were readily available. The scientist gestured to historical data projecting above the chamber. Humans evolved on a world with limited resources and developed technologies under constant resource pressure. Every innovation in human history was driven by the necessity to do more with less. Their engineering traditions developed around the assumption that materials, energy, and time were precious and scarce. Council member Vothran's shipping calculations were becoming increasingly agitated. You are suggesting that resource scarcity made humans better engineers than resource abundance made us? I am suggesting that resource scarcity made humans different engineers than resource abundance made us, Dr. Cathmori corrected. And, in the current galactic context, their approach may be more valuable. The implications were staggering. For 12,000 years, the Federation had operated under the assumption that technological superiority naturally arose from having the best materials, the most energy, and the most sophisticated manufacturing techniques. Dr. Cathmori, Chairman Vextar said slowly, are you recommending that the Council approve human testing of their manufacturing technologies? Before the scientist could respond, urgent alerts began flashing throughout the chamber. Emergency communications from multiple star systems demanded immediate attention. The primary display screen activated, showing Admiral Kreshta of the Federation fleet, her reptilian features twisted with concern. Chairman Vextar, we have a developing situation in the Kepler 442 system. Long-range sensors are detecting massive construction activity around the fourth planet. Estimated completion of what appears to be a planetary defense grid within 48 hours. The chamber fell silent. Planetary defense grids typically required months or years to construct, even using the most advanced Federation technologies. Admiral, Chairman Vextar managed, what species is responsible for this construction activity? That's the problem, Chairman. The planet is inhabited by the Veltar, a pre-industrial civilization that only achieved chemical rockets 3 years ago. They should not possess the capability for orbital construction projects. The implication was obvious to everyone in the chamber. The Veltar had somehow acquired human manufacturing technologies. Admiral, Dr. Cathmori interrupted, what is the construction methodology? Are you observing traditional assembly techniques or something else? Something else, Doctor. Our tactical analysts describe it as viral construction. Small objects appear in orbit, attached to space debris and asteroids, then grow into larger structures. Each new structure produces more small objects, which spread throughout the system. The description matched Marcus Chen's demonstration exactly. Somewhere in the galaxy, humans had shared their emergent engineering technologies with a species that was using them to build planetary defenses. Council member HFY's energy form was flickering so rapidly it was becoming difficult to look at directly. Admiral, what is the defensive capability of these growing structures? Unknown, Counselor. But, the rate of expansion suggests that the entire system will be fortified within 2 weeks. If this civilization has hostile intentions. The Admiral's transmission was interrupted by another emergency alert. This one came from the Federation's Intelligence Division. Director Mothak appeared on the secondary display, her insectoid features vibrating with agitation. Council members, we have confirmed reports of similar construction activity in 6 additional systems. All involve civilizations that were classified as pre-industrial within the last decade. The scope of the situation was becoming clear. Human engineering technologies were spreading throughout the galaxy, providing advanced manufacturing capabilities to civilizations that had been considered primitive just months earlier. Director, Chairman Vextar demanded, how are these civilizations acquiring human technologies? Through direct technology transfer, Chairman. Human engineering teams are visiting non-Federation worlds and providing manufacturing seed units along with basic operating instructions. They describe it as development assistance. The revelation sent the chamber into chaos. Several delegates immediately began urgent communications with their intelligence services, demanding information about human activities in their territories. Director Mothak, Dr. Kethmori called over the noise. What are the humans requesting in return for these technology transfers? Nothing, Doctor. No payment, no territorial concessions, no political agreements. They provide the technologies freely and offer basic training in their use. The only requirement is that recipient civilizations agree to share the technologies with other species upon request. The statement was so unprecedented that several translators required multiple attempts to render it accurately. The concept of sharing advanced technologies without compensation violated every established principle of galactic economics and politics. Chairman Vextar finally restored order to the chamber. Director, what is the human justification for this unprecedented technology sharing? Director Mothak consulted her data files before responding. According to intercepted human communications, they believe that technological advancement benefits everyone. They describe it as accelerated development and claim that lifting other civilizations enhances galactic stability. The explanation was so contrary to established thinking that most delegates couldn't process its implications. For thousands of years, technological advantage had been carefully guarded as a source of economic and military power. Director, Council Member RYTHOK rumbled through his translator, what is the strategic assessment of human intentions? Unknown, Counselor. Human behavior patterns do not match any recognized expansion or conquest strategies. They appear to be genuinely interested in helping other civilizations develop advanced manufacturing capabilities. The intelligence director paused, consulting additional reports. There is one additional factor, Counselor. Human engineering teams consistently emphasize that their technologies work best when multiple civilizations are using them simultaneously. They describe it as network effects. The more species that adopt emergent manufacturing, the more valuable the technologies become for everyone. Dr. Kethmori's analytical mind immediately grasped the implications. Director, are you suggesting that human technologies become more effective as they spread? According to human technical documentation, yes. Their manufacturing systems are designed to learn from each other across interstellar distances. Each new implementation improves the capabilities of all existing implementations. The concept was revolutionary. Traditional galactic technologies were competitive. The more species that possessed them, the less valuable they became. Human technologies appeared to be cooperative. The more species that possessed them, the more valuable they became for everyone. Council members, Dr. Kethmori announced, his voice carrying new urgency, we are facing a paradigm shift that extends far beyond simple manufacturing technologies. Humans have developed cooperative engineering methodologies that become more powerful through proliferation, not less. He activated new displays showing network topology diagrams. If my analysis is correct, every civilization that adopts human technologies becomes a node in an expanding manufacturing network. The network becomes more sophisticated, more capable, and more efficient as it grows. The implications were staggering. Instead of competing for limited technological advantages, galactic civilization could participate in an expanding technological network where everyone's capabilities improved as the network grew. But, Chairman, Council Member Vothran interjected, what happens to civilizations that choose not to participate in this network? What happens to the established galactic economy? The question struck at the heart of everyone's concerns. The Galactic Infrastructure Council represented trillions of credits and investments and employed billions of beings across dozens of star systems. If human technologies made conventional infrastructure obsolete, the economic consequences would be catastrophic. Dr. Cathmory's response was measured but ominous. Counselor, based on preliminary analysis, civilizations that do not adopt emergent manufacturing technologies will find themselves at an increasingly severe disadvantage. The cost differential between conventional and emergent manufacturing appears to be exponential, not linear. He displayed comparative projections showing cost curves over time. Within 5 years, a civilization using emergent manufacturing could produce infrastructure at 1,000th the cost of conventional methods. Within 10 years, the ratio could be 1/1,000,000th. Conventional manufacturing would become economically unviable. The projections showed traditional galactic industries withering and dying as human technologies spread. But they also showed unprecedented growth in overall galactic manufacturing capacity and technological sophistication. However, Dr. Cathmory continued, the same analysis suggests that civilizations which adopt emergent manufacturing early would experience unprecedented economic expansion. The total value created by the galactic economy could increase by several orders of magnitude. Chairman Vextar studied the projections with growing alarm and fascination. Dr. Cathmory, are you suggesting that human technologies could make the entire galactic economy obsolete while simultaneously making it vastly more productive? That is exactly what I am suggesting, Chairman. Human engineering appears to represent a transition from scarcity-based economics to abundance-based economics. The transition would eliminate existing economic structures while creating far more productive ones. The concept was so transformative that several delegates required translation assistance to fully understand its implications. Council member HFY Stories' energy form stabilized as she processed the information. Dr. Cathmory, such a transition would require fundamental changes in how galactic civilization operates. Government structures, legal frameworks, social institutions, everything would need to be reconsidered. Correct, Counselor. The transition would be comparable to the agricultural revolution or the industrial revolution, but occurring across multiple species simultaneously. The scientist paused, considering the magnitude of his next statement. According to human historical data, such transitions are inevitable once they begin. Civilizations that adapt early gain enormous advantages. Civilizations that resist adaptation eventually find themselves unable to compete with adapted ones. The chamber fell silent as delegates contemplated the choice facing galactic civilization: adapt to human engineering methodologies or become irrelevant as the galaxy evolved around them. Council members, Chairman Vextar announced finally, it appears we are not merely considering whether to approve human membership in the Federation. We are deciding whether to participate in or resist a transformation of galactic civilization itself. He looked around the chamber at representatives of the most powerful civilizations in known space. I am calling for an immediate vote on emergency authorization for human technology testing. The question before us is simple: do we want to help shape this transformation, or do we want to be shaped by it? The vote was closer than anyone had expected. When the results were announced, emergency authorization had passed by a single vote. Within hours, Dr. Marcus Chan received authorization to activate his manufacturing seed unit in a controlled environment near the galactic headquarters. The test would be monitored by the finest scientists and engineers in Federation space. But, as Marcus prepared for the demonstration that would change the course of galactic history, reports continued arriving from across the galaxy. Human technology transfers were accelerating. More civilizations were developing advanced manufacturing capabilities. The emergent engineering network was expanding exponentially. The moment when human engineering made galactic infrastructure obsolete was no longer a future possibility. It was happening now, across dozens of star systems, whether the Federation participated or not. Marcus Chen smiled as he made final preparations for the demonstration. The man who had destroyed his weak assumptions about engineering limitations was about to prove that no external force could destroy the power of human innovation. The galaxy was about to discover that humans had spent their entire history preparing for this moment, the moment when scarcity would become abundance, when limitation would become possibility, and when the impossible would become inevitable. The observation deck of the Galactic headquarters had been converted into the most sophisticated monitoring station in Federation history. Every major scientific instrument in the sector was trained on the small section of space where Dr. Marcus Chen would activate his manufacturing seed unit. Representatives from 47 member civilizations crowded around displays showing real-time sensor data. The tension was palpable as scientists, politicians, and military officers waited to witness either the greatest breakthrough or the most spectacular failure in galactic engineering history. Marcus stood at the central control station, the metallic sphere resting in a specialized launch mechanism. His calm demeanor contrasted sharply with the barely controlled excitement surrounding him. Dr. Chen, Chairman Vexstar announced, "You are cleared to begin your demonstration." Marcus nodded and activated the launch sequence. The sphere emerged from the station and drifted toward a collection of debris that had been specially arranged for the test: discarded hull plating, exhausted fuel containers, and various mechanical components representing typical space waste. For the first 20 minutes, nothing visible happened. The sphere drifted through the debris field, occasionally making contact with larger pieces but showing no obvious signs of activity. Dr. Chen, Dr. Kethmori asked, "Should we be observing some indication of activation?" "The initial phase is entirely microscopic," Marcus explained, gesturing toward displays showing molecular-level sensor data. "The seed unit is releasing self-assembling machines approximately 1 nanometer in length. They're currently mapping the atomic structure of available materials." The molecular displays showed tiny structures moving through the debris, analyzing and cataloging everything they encountered. The process looked more like biological activity than mechanical engineering. Dr. Kethmori, council member THYSSERA, observed, "These structures appear to be exhibiting behaviors similar to bacterial colonies." "That's an accurate comparison, Counselor," Marcus confirmed. Human engineers studied biological systems extensively while developing emergent manufacturing techniques. "We discovered that nature had already solved most of the engineering problems we were trying to address." The displays began showing the first signs of visible activity. Nanoscopic machines were organizing themselves into larger structures, creating tool-sized devices that began reshaping the debris. "The manufacturing process operates in phases," Marcus explained as the observer delegates watched in fascination. "Phase 1 involves reconnaissance and resource mapping. Phase 2 involves tool construction. Phase 3 involves factory construction. Each phase builds the capabilities needed for the next phase." By the second hour, the debris field was visibly changing. Pieces of scrap metal were being systematically disassembled and reorganized into new configurations. What had been random junk was becoming ordered structures. Dr. Kethmori's instruments registered unprecedented readings. "Dr. Chen, the energy efficiency of this process exceeds our theoretical maximums." "How is this possible?" "Because you're measuring efficiency against conventional manufacturing assumptions," Marcus replied. "Conventional manufacturing involves imposing order on materials through external force. Emergent manufacturing involves creating conditions where materials organize themselves." He gestured toward the displays showing energy consumption data. "When you force materials into new configurations, you must overcome molecular bonds and overcome natural resistance. When you create conditions for materials to reorganize themselves into more stable configurations, they actually release energy during the process." The concept challenged fundamental assumptions about thermodynamics and manufacturing efficiency that had guided galactic engineering for millennia. Dr. Chen, Chairman Vexstar, interjected, "Are you suggesting that your manufacturing process generates energy rather than consuming it?" "During certain phases, yes. The overall process still requires energy input, but much less than conventional manufacturing because we're working with natural tendencies rather than against them. By the fourth hour, the debris field had been transformed into a sophisticated manufacturing complex. Structures that had started as random scrap were now functioning as advanced fabrication facilities. Council member RYTHOK's rumbling translator conveyed his amazement. Dr. Chen, the rate of construction exceeds our fastest automated assembly systems by factors of 10. How is such speed possible? Because we're not building one structure, Counselor. We're building thousands of structures simultaneously. Marcus highlighted different sections of the growing complex. Each microscopic machine is an independent constructor. They coordinate their activities through local communication, but each one operates autonomously. Instead of one large construction project, you're observing millions of tiny construction projects happening in parallel. The parallel construction concept was revolutionary. Conventional galactic engineering involved sequential assembly, building components in order and assembling them according to predetermined plans. Human engineering involved simultaneous assembly, building all components at once and allowing them to organize themselves into optimal configurations. Dr. Cathmori, Dr. Chen continued, your sensors should now be detecting something interesting about the factory structures themselves. The chief scientist checked his instruments and displayed the results for the entire observation deck. The manufacturing facilities are improving themselves. Each generation of tools is more sophisticated than the previous generation. Exactly. This is the key difference between conventional and emergent manufacturing. Your systems build predetermined structures using predetermined techniques. Our systems build evolving structures using evolving techniques. By the 8th hour, the original debris field had become unrecognizable. In its place was a complex that resembled a combination of city and organism structures that grew and adapted while simultaneously producing increasingly sophisticated components. The manufacturing complex is now entering its productive phase, Marcus announced. It will begin producing components for external use while continuing to improve its own capabilities. The first products to emerge from the complex were communication devices more advanced than anything in the Federation's inventory. Within minutes, these were followed by power systems, computational devices, and construction equipment. Dr. Chen, Council Member Vothran asked with growing alarm, what determines what the complex produces? Need and opportunity, Counselor. The manufacturing systems analyze their environment, identify useful products to create, and begin production. The only limitation is available materials and energy. As if to demonstrate his point, the complex suddenly began producing what appeared to be transportation devices, small spacecraft designed for interplanetary travel. The complex detected our observation platforms and determined that improved transportation would be useful for the observers, Marcus explained casually. Those ships are now available for anyone who wants to take a closer look at the manufacturing processes. The offer caused immediate security alerts throughout the observation deck. The idea of boarding human-manufactured spacecraft raised numerous safety concerns. But Dr. Cathmori's scientific curiosity overcame his caution. Dr. Chen, I would very much like to examine these vessels more closely. Within 30 minutes, a small group of volunteers was aboard one of the newly manufactured ships, examining construction techniques that defied conventional understanding of materials science and engineering. Chairman, Dr. Cathmori reported via communication link, the structural integrity of this vessel exceeds our best military spacecraft. The materials are unlike anything in our databases, but they appear to be composed entirely of elements that were present in the original debris field. The report sent shockwaves through the observation deck. The idea that random space debris could be transformed into advanced spacecraft materials challenged basic assumptions about chemistry and physics. How is this possible, Dr. Cathmori? Chairman Vextar demanded. The manufacturing complex appears to have reorganized common elements into exotic atomic configurations. Iron atoms arranged in crystalline matrices that should not be stable, but clearly are. Carbon structures with properties that our materials science cannot explain. Marcus nodded in satisfaction. Dr. Cathmori, you're observing the difference between conventional chemistry and emergent chemistry. Your scientists study how elements behave under natural conditions. Human scientists learn to create unnatural conditions where elements behave in new ways. The implications were staggering. If humans could manipulate atomic structures to create materials with impossible properties, conventional limitations on engineering and manufacturing no longer applied. Dr. Chen, Chairman Vextar said slowly, you are demonstrating capabilities that approach what we would consider technological magic. With respect, Chairman, there is no magic involved. Only engineering principles that your civilization hasn't discovered yet because you never needed to discover them. Marcus gestured toward the thriving manufacturing complex. Every technique you've observed today was developed by human engineers working with limited resources and primitive tools. We learned to manipulate atomic structures because we couldn't afford exotic materials. We learned emergent manufacturing because we couldn't afford massive factories. We learned cooperative technologies because we couldn't afford to waste anyone's innovations. By the 12th hour, reports were arriving from across the galaxy. Other human manufacturing demonstrations were producing equally spectacular results. Civilizations that had received human technology transfers were reporting unprecedented increases in manufacturing capability and economic productivity. Dr. Chen, Director Mathek announced via communication link, our intelligence indicates that 17 civilizations have now achieved space elevator construction capabilities using your technologies. 14 others have developed orbital manufacturing complexes. 6 have begun interstellar infrastructure projects. The speed of technological proliferation was unprecedented in galactic history. Traditional technology transfer between civilizations typically required decades or centuries. Human technologies were spreading across the galaxy in months. Director, Dr. Cathmori asked, what is the strategic assessment of this technological expansion? Unprecedented, Dr. We are observing the emergence of a galactic manufacturing network that appears to be self-improving and self-expanding. Each new node increases the capabilities of all existing nodes. The network effects Marcus had described were becoming visible on a galactic scale. Civilizations using human technologies were not only improving their own capabilities but contributing to improvements throughout the network. Dr. Chen, Chairman Vextar asked with growing concern, what happens to civilizations that choose not to participate in this network? Marcus considered the question seriously before responding. Chairman, that would be like asking what happens to agricultural civilizations that choose not to participate in industrialization, or what happens to horse-drawn transportation systems that choose not to participate in mechanization. The analogy was clear and ominous. Civilizations that failed to adopt transformative technologies eventually found themselves unable to compete with those that did. But, Chairman, Marcus continued, unlike previous technological transitions, human emergent manufacturing is designed to be inclusive rather than exclusive. We want every civilization to participate because the network becomes more valuable for everyone when everyone participates. He gestured toward the manufacturing complex, which had continued growing and improving throughout their conversation. The goal isn't to dominate galactic civilization through technological superiority. The goal is to elevate galactic civilization through technological cooperation. Council member HFY Symphony's energy form had stabilized to what her species associated with deep contemplation. Dr. Chen, you are proposing to transform not just galactic manufacturing, but galactic culture. Moving from competitive to cooperative technological development. That's exactly what I'm proposing, Counselor. Human history taught us that cooperation produces better results than competition when dealing with complex technological challenges. The statement challenged 12,000 years of galactic tradition. The Federation had been built on the assumption that technological competition drove innovation and progress. Dr. Chen, Dr. Cathmori interjected, human cooperation may have been effective for your single-species civilization. But, galactic civilization involves hundreds of species with different evolutionary backgrounds, different resource needs, different cultural values. How can cooperation work on such a scale? Marcus smiled, the first genuinely pleased expression he had shown since arriving at Galactic headquarters. Dr. Cathmori, That's exactly why cooperation works better on a galactic scale than on a planetary scale. The more diverse the participants, the more innovative the solutions become. He activated new displays showing comparative analysis of technological development across different civilizations. Every species in the Federation evolved different solutions to similar problems. Your people developed gravitational manipulation. The Zephyrians developed energy-based manufacturing. The Kronak developed massive-scale construction techniques. The humans developed emergent manufacturing. The display showed how different technological approaches could be combined and enhanced through network cooperation. Individually, each approach has limitations. Combined through networked cooperation, each approach enhances all the others. Gravitational manipulation makes emergent manufacturing more efficient. Energy-based manufacturing makes construction techniques more precise. Massive-scale construction makes gravitational manipulation more effective. The concept was revolutionary. Instead of competing technologies replacing each other, cooperative technologies could enhance each other. Dr. Chen, Chairman Vextar announced, "Your demonstration has exceeded all expectations. The Council must now decide how the Federation will respond to your technological offerings." But, even as the chairman spoke, new reports were arriving that made the decision increasingly urgent. Human technology transfers were accelerating across the galaxy. The emergent manufacturing network was expanding exponentially. Civilizations that joined early were experiencing rapid economic and technological growth. Civilizations that remained outside the network were falling increasingly far behind. Chairman, Director Mafek reported, "We now have confirmation that non-Federation civilizations using human technologies are beginning to outperform Federation members in multiple economic and technological metrics. The strategic implications are becoming critical." The message was clear: the Federation could join the transformation or be left behind by it. Dr. Chen, Chairman Vextar said finally, "Humanity's petition for Federation membership is approved. But, more than that, humanity is invited to lead the Federation's transition to emergent manufacturing technologies." The decision marked the end of one era and the beginning of another. The age of scarcity-based galactic civilization was ending. The age of abundance-based galactic civilization was beginning. As Marcus Chen shook hands with Chairman Vextar, sealing humanity's entry into galactic civilization as technological partners rather than junior applicants, the manufacturing complex around them continued to grow and evolve. The complex now spanned several cubic kilometers and was producing everything from advanced spacecraft to exotic materials to sophisticated computational systems. More importantly, it was producing copies of itself, seeds that would spread emergent manufacturing throughout the Federation. Chairman Marcus said as they watched new seed units launching toward distant star systems, "This is only the beginning. Human engineers have been working on challenges that make emergent manufacturing look simple." The statement sent a chill through the assembled delegates. If emergent manufacturing was just the beginning of human engineering capabilities, what else were they capable of? Dr. Chen, Dr. Kethmori asked with scientific curiosity overcoming his apprehension, what challenges could possibly be more complex than reorganizing matter at the atomic level? Marcus looked out at the vast expanse of space surrounding galactic headquarters, where stars burned with ancient energy and civilizations struggled with the fundamental limitations of physics and time. "Dr. Kethmori," he said quietly, "have you ever wondered why space is so empty? Why civilizations are separated by such vast distances? Why communication across interstellar space takes years, and travel takes decades?" The questions struck at fundamental assumptions about the structure of the universe. Those aren't natural limitations, Doctor. They're engineering challenges that no civilization has solved yet. But, human engineers have been working on them for decades. The implications were staggering. If humans could solve the problems of interstellar distance and communication, the scope of galactic civilization would expand beyond current imagination. Dr. Chen, Chairman Vextar asked slowly, "Are you suggesting that humanity has developed technologies for faster-than-light communication and travel?" Marcus's smile became enigmatic. "Chairman, I'm suggesting that human engineers approach problems differently than galactic engineers. You see interstellar space as empty void that must be crossed. We see it as a medium that can be engineered. As the meeting concluded and delegates began returning to their respective governments, the manufacturing complex continued its exponential growth. The transformation of galactic civilization had begun, driven by the simple principle that had guided human engineering for millennia: there are no limitations, only engineering challenges waiting to be solved. The man who had destroyed his weak assumptions about engineering possibilities had proven that no external force could destroy the power of human innovation. And, as the emergent manufacturing network spread across the galaxy, it carried with it the promise that this was only the beginning of what human engineering could accomplish. In the depths of space, where civilizations had struggled with scarcity for millions of years, abundance was finally becoming possible. The age of limitations was ending. The age of